Hello, my name is Chen Yangma, and welcome to my Capstone project presentation. I am a senior at the University of Michigan with major in computer engineering. The title of my capstone project is Learning Material Property from Video Tactile Associations. This research project is under the supervision of Professor Andrew Owens and falls under the category of computer vision and robotics. As human beings, we perceive and learn about our world using our eyes, nose, ears, and hands. We have access to many sensory streams, and we learn from associations between different senses. When a child eats an apple, for instance, she will not only taste it, she will also hear it crunch, see its shiny skin, and feel its smooth surface. However, for robots, it is not the case. Most recent work on robots has been based only on visual inputs, and these robots are unable to combine visual information with other sensory modalities to improve its perception. In this research project, we try to integrate the visual information and touch information to create a more powerful multisensory perception system. To achieve our goal, we try to retrieve touch information using geosets, a specially designed tactile sensor to learn the material properties of objects. We combine them with visual information captured by Logitech Pro camera. The geoset is manufactured by Carnegie Mellon University. It has a soft contact interface and provides high-resolution tactile images of contact geometry as well as contact force and sleep conditions. With these two sensors, the Geoset and the Logitech Pro camera, we made three contributions. For the first one, we collected the first egocentric dataset of video plus tactile data. Our dataset contains 2 hours of video, 20 objects, 1,000 touches with a tactile sensor. We are still expanding our dataset. Our dataset contains both outdoor and indoor scenes. This is a demo of an outdoor scene. We collected the video and tactile data of stones in the wild. And here is a demo of an indoor scene. We collected the video and tactile data of walls in the BBB building at the University of Michigan College of Engineering. To prove the robustness of our dataset, we developed a deep learning model for manipulating the appearance of an object to match its material property, a problem we term tactile-driven image sterilization. Our model learns through cell images through self-supervised learning. Given a dataset of paired visual and tactile data, the model learns to manipulate the image such that, after manipulation, the object in the image transforms its material property. For example, when we want to make an object harder, or we want to make a carpet becomes a wooden plank. We also empirically found that changing the tactile signal in the mixture results in predictable visual changes. The deep learning model we developed is a modified model based on the model proposed in the research paper, Contrastive Learning for Unpaired Image Translation. We pass the inputs of RGB image I and the tactile image T into two separate decoders labeled in the pink and the green box with linear concatenation. The fake image I prime is generated using the decoder, which is the blue one. The generated fake image I prime is then fed into the discriminator and the same pink encoder for calculating the loss to update the parameters in the deep learning model. The example using this figure is a stone. Given the RGB image of the stone and the tactile signal for grass, the stone is restyled such that the grass grows on the surface of the stone. We obtained pretty good results in visualizations using our dataset. Again, I and T, which are the original RGB images and the tactile signals, are the inputs, and I prime, the generated fake images, are the outputs. In the first, third, and fifth columns, we restyle stones into a pile of grass. It is interesting to see how each generated fake images are different. In the first and the third column, as the size of the stone is large, we feel like the grass grows on the surface of the stone, and we can still see the outer shape of the stone in the generated fake images. In the fifth column, as we have many stones and their size is small, each stone is turned into a grass ball. In the third and the fourth column, we restyle the grass into stones. In the second column, the entire scene of the grass changes into stones, while in the fourth column, a large stone magically appears at the center location of the grass, while the surroundings remain unchanged. We have a lot more interesting results. In number 1, the leaves grow out of a brick wall. In 2, the texture of the brick wall becomes the texture of a road. In 3, leaves grow out of a tree. In 4, a stone in some dry leaves transforms into a road. In 5, the scene of a tree restyles into some kind of painting, given the tactile signal of a wall. In number 6, the wall transforms into a brick wall. To further prove the robustness of our dataset, we are also working on a novel multisensory video prediction program. Given an image plus tactile signal, we want to predict the next frame tactile signal. For example, if we are pressing a soft object, then a tactile signal should show more information than a hard object. Or we want to predict the next frame visual image. For example, if we stop pressing, our hand is likely to move off the object. This is still in progress, and we will have results very soon. For next steps, first we will expand the diversity of our dataset. Currently, we mainly have stone, grass, brick, carpet, tree, and roads in outdoor scenes. We also have walls and a lot of indoor stuff. We want to expand from 2 hours of video, 20 objects, 1,000 touches, into at least 10 hours of video, 50 plus objects, and 5,000 plus touches. We will also continue to work on video prediction task, and finally, we will write a research paper and submit to an international conference very soon. For acknowledgement, I want to thank you for the supervision of Professor Andrew Owens, and also special thanks to Professor Wen Zhenyuan from Carnegie Mellon University for providing us geosites for this research. Thank you for your time, and you are welcome to leave questions in the comment section. I will do my best to answer all of them.